Let's look at proposition 13 of book 3 of Euclid's Elements. The proposition says that a circle cannot touch another circle at more than one point. And it also says whether it is touching internally or externally. In either case, it can't touch it more than at more than one place. Okay, let's see. Let's look at the internal case first. I know again, this is not a circle, but for the purposes of arriving at the proof, let's imagine that this is a circle which is touching another circle at 2 points. And these 2 points are B and D. Let's join these 2 points. Again, in one of our previous propositions, we saw that the centers of the circle, if they are joined, they pass through the point of contact. So that means the center lies on this line. So let's say that G is the center of circle C and H is the center of circle E. Purely based on this, we can arrive at a contradiction. Let's see. We know BG is equal to GD. Remember, we are assuming that G is the center of the circle C. So that means BG is equal to GD because they are the radii of the same circle. Similarly, BH is equal to HD because they are the radii of the same circle. And remember here, circle C is the exterior circle. And the circle E is the interior circle. So here, if this is the center of the green circle, that means GD is greater than HD. Now, if GD is greater than HD, what does it imply? It implies that BH is much greater than HD. But we started off by saying that this is BH is equal to HD because they are the radii of the same circle. And now we are arriving at a contradiction that BH is much greater than HD. So because of this contradiction, we can say that this situation is not possible. So our assumption was wrong. That means a circle, if it touches another circle internally, then it touches it at only one place. This was the case of internal circle. Okay, now let's look at the external case. So let's hide all these things. And now let's say we have another circle which is supposed to touch this green circle two places. Two places we are going to prove that it is not possible. So which means it can touch only at one place. But here it is actually cutting the circle. So again we come out with some, fancy kind of figure. So let us say this is the circle which is touching the circle C at 2 points, C and A and C. Immediately you should notice something, that if we join these 2 points, A and C, what happens? Remember, point A and C are points on both the circles. It is there on circle C and it is there on the circumference of circle E as well. So remember one of the previous propositions, if 2 points at random are taken on a circle, and if you join those 2 points, then the segment lies inside the circle. So here what is happening? Here these 2 points A and C, they lie on this circle as well as this circle's circumference. But is the segment inside both the circles? It is there inside the circle C, but it is outside the circle E. So which means this is a situation which is not possible, since we have arrived at a contradiction, which again means that our assumption was wrong and this circle can touch this circle only at one point or 0 points, it may not touch at all. But the point is, if it touches, it can touch only at one point. That is proposition 13. Remember these kind of funny figures, which visually when you look at it, it seems impossible by looking at it. But we should be able to prove it based on our previous proposition. That's where the trick comes. Okay, so that was proposition 13 of book 3. Let me remind you again, there is a link to a PDF book in the video description. Please feel free to download it, refer to it, and if you feel somebody else will benefit, please do share it. That's it for now.